Hello, in this video we will learn how to multiply radicals. So to multiply radicals there is nothing new actually, just seeing it in a different way. So let's say that you had these two radicals, a over b times c over d, and you want to multiply them. So our result would just be a times c over b times d. Of course, there is something to keep in mind. Now that you have this, you can actually find the common factors of AC and BD and cancel them out. However, most of the times, there is no need actually to multiply A times C and B times D if you can also do, if C and D are already simplified, C over D and A over B are already simplified, just also check common factors of A and D and B and C and cancel accordingly. So let's work on a very simple example first. So let's say that you have 30 over 13 times 26 over 15. So if this is the case, it is evident that 30 over 13 is simplified and 26 over 15 is simplified to lowest terms. However, when you're multiplying them, instead of having to do 30 times 26 over 13 times 15 and then finding the common factors and canceling them out after you did these huge multiplications, what you could do since the beginning is just look at the common factors of 30 and 15. So 30 is kind of our A before and 15 is our D. And also look at the common factors of C and B. So the common factors of 30 and 15 is actually 15. So 15 divides both of them. And so you can just cancel them out, and instead of having 30 over 13 times 26 over 15, you could actually just have 2 and 1 right here. But now we also want to see if there are any common factors between 26 and 13. And so you will see that there is. So 26 and 13 have a common factor of 13. 13 divides both 26 and 13. And so we could actually just cancel them out and replace also by 2 and 1, because 13 goes into 26 two times, so we have a 2 right here, and 13 goes into 13 just one time, so we have the 1 right there, and this is equal to 4, which is much simpler and faster than what we did at the beginning. So now we'll do something very similar, but just having a slightly bigger function in the numerator and denominators. So in this case, instead of multiplying everything like we did the first time in the other case, you could find the common factors of 2x minus 4 and 4x minus 8. So if you have 2x minus 4, you could see that you can factor out a 2 and get x minus 2. And if you have 4x minus 8, you could actually factor out a 4 and get x minus 2. However, here we see that actually 2 and 4 have a common factor themselves, which is 2. So we can just decide to have this as our common factor for 2x minus 4, which is and 4x minus 8, which is just 2x minus 4. So by doing that, We know that if we were to divide this by 2x minus 2, this 2 would actually cancel out, and here you would be left with a 2. And so we'll do exactly the same thing we did in the other case where we had only numbers. So we just replace by whatever we decided to divide by. So 2x minus 4 divided by 2x minus 4 is equal to 1. We haven't found if there is a common factor between 3x plus 15 and x plus 5. So by now we just leave it blank. And 4x minus 8 divided by 2x minus 4 we decided was 2. So now just to find the common factor of x plus 5 and 3x plus 15, we see that x plus 5 cannot be factored out anymore. However, 3x plus 15 can be factored out to 3 times x plus 5. We see that x plus 5 is a common factor of both of them. So we can replace x plus 5 just by 1 and 3x plus 15 just by 3, because eventually you would just cancel them out when you divide them. So right here we substitute 3x plus 15 just by a 3 and x plus 15 by a 1. And we get that this is equal to 1/6, which is much simpler than what we had before.